Hello guys, welcome to Ramta Solutions and welcome to your grade 12 analytical geometry. In this video, we are going to look at the equation of a circle, and to be precise, we're looking at the circle centered at the origin. Okay, so the scope of this video is that we're going to derive the formula that we use for circle with center at the origin and conclude with worked examples. So you have seen this video, you have seen this equation or this formula before, right? So now we're going to derive it for use of a circle. Okay, we're going to derive it for use of a circle. So without any waste of time, let's get into it. So let's say formula derivation. Okay, let's say formula derivation. That's the first thing that we're starting with. Okay, so I'm going to let me just create a grid. I'm going to draw some straight lines and then draw a circle. Okay, and draw a circle. Okay, and then right. So we're gonna call these the y-axis and this the x-axis. And then I'm also gonna use a protractor. I want to draw a circle. Okay, and let me use a compass. Okay, let me use a compass. Okay, let me use a compass. Okay, it's fine. Let me draw the circle here. Okay, so this is our circle. Thank you. So this is our circle. Thank you, buddy. So this is our circle. Now I want you to imagine now, let's say a point from the center to a line from the center to the circumference. So we're gonna call this point here, let's call it point P with coordinates X and Y. Okay, of course this is the origin. Okay, now what we know, you guys recall that we did distance, right? So we can say distance, if you recall distance OP, we can basically say it's the square root, right? It's the square root. The square root of what? It's the square root of X sub P minus, let me remove the grid. It's the square root of X sub P minus X sub O all squared plus Y sub P minus Y sub O all squared. By the way, let me remove the square root by squaring both sides, so it'll be OP squared. By the way, may I also call OP radius? As you can see, the center of the circle is the origin, so OP is a radius, okay? So it'll be OP squared, okay? OP squared equals, we have X of P minus X of O all squared plus Y of P minus Y of O all squared. What is OP? We said OP is the radius which we call in R, so it'll be R squared. Now we have X of P is X. What is Y of O? X of O. X of O, this is the origin. At the origin, the coordinates are 0 and 0, so it's 0. What is Y of P? We're calling it Y. What is Y of O? Y of O is 0, right? So this therefore says we have X squared plus Y squared. So this one here is your equation of the circle with center as the origin. Okay, it's equation of your circle with center as the origin. So in summary, we are saying X squared plus Y squared equals R squared. Of course, you know this as Pythagoras theorem, right? Of course, you know this as Pythagoras theorem, right? So this is your equation of the circle with center at the origin. Okay, goes like this. So this is how you go about this, guys. This is how you go about this. Now we are going to try some few examples. Okay, we are going to try some few examples. So without any waste of time, let's head to word examples. So item 2, word examples. All right, item 2, word examples. And by the way, guys, remember this equation only works when the center of your circle is the origin. Okay. Now, word example, I will say, okay, let me call it example 1. Determine the equation of the circle. Determine the equation of the circle. The following. 1. Roman figure 1. We have a circle. Let me just draw a circle. We have a circle here, and then it's passing at the origin, and there's a point here which is -3, 2. Okay, so of course this is the y value, this is the x value. And then question 2, it says circle with center, right? Circle with center at the origin. Okay, circle with center at the origin and a radius of 4 units. A radius of 4 units. Roman figure 3 or question 3 will be circle with center at the origin. Circle with center at the origin. Okay, circle with center at the origin and passing through point √3, 1. Okay, passing through point √3, 1. Okay, so these are our examples. Okay, these are our examples. So we're going to look at example 1. Example 1, I might even do it here. Example 1, as you can see, it's circle at the center. Alright, it's circle at the center. Oh no, let me do it in the next page. So our solutions for circle with center, not circle at the center. For circle with center at the origin, Roman figure 1, we have x squared plus y squared plus, oh no, equals r squared. What are the values of x and y that we got? -3 and 2. So x is -3 all square, y is 2 square. This is r squared. What is this? This is 9 plus 4, right? This is 13. Therefore, equation of the circle with center, with origin as the center, is x squared plus y squared equals 13, isn't it? Okay, so this is our equation. Okay, now Roman figure 2, okay, let me start it here. Roman figure 2, they're saying circle with center at the origin and a radius of 4 units. This is okay. We know this is x squared plus y squared equals r squared. We are given the radius. They're saying the radius is 4 units. Alright, they're saying the radius is 4 units. Okay, so what is this? What does r we put for? Like you have seen, r is the radius. Okay, so this is x squared plus y squared equals 16. This is our equation. Alright, this is our equation. Now, question number 3, we're looking for equation of the circle with center at the origin and passing through √3 and 1. Cool. It's passing through √3 and 1. So this is x squared plus y squared equals r squared. The point is √3 and 1, isn't it? It's √3 and 1. Let me confirm if it's okay. It's not negative values. It's √3 and 1. So what we're going to do, whether it's x, we put √3, where there's y, we put 1. All right, what is this? This is 3 plus 1. All right, what is this? R squared is 4. Therefore, our cycle is x squared plus y squared equals r squared. Okay, guys. So this is how, oh no, not equals r squared. Equals 4, because we said r squared is 4. All right, we said r squared is 4. So this is how you determine the equation of, your circle with center at the origin. Okay. So whenever you are given the information that center is the origin, don't waste your time. Just say x squared plus y squared is equal to r squared. Remember r being your radius. And remember, radius of the circle is the same throughout the circle, right? As long as it's moving from the center to the circumference, radius is the same throughout, isn't it? Oh yeah. All right. So with this being said, guys, we have come to the end of our lesson. And with that being said, I want to say, if you want to get in touch with us, you can contact us on our website. You can use this information. Our website is www.ramtasolutions.co.za. On the very same website, you will find all these icons. You will find them. This being, when you click on it, it will open a mailbox that you can send us an email. And this, of course, is where you're watching this video on YouTube. You can subscribe, like the video, and of course, share with your friends and classmates. Okay. You can follow us on your favorite social media platforms. And in addition, in the very same website, you will see a WhatsApp icon. If you click on the website, on the WhatsApp icon, you will be directed to your WhatsApp and you can send us a message if you want to talk to us. Again, if you're looking for a tutor, you can also talk to us on WhatsApp. Okay. I hope this is helpful, guys. And yeah, this is it, guys. So before I conclude, let me emphasize the point once again. This formula, you use it as it is when your circle is centered at the origin. Okay? So with that being said, our ends here, and bye-bye.